Functions by Brady, Mackenzie, Sophia, and Hajar. Exponential growth. Every weekend I spend double the time on the computer than I did before. I spend 30 minutes. So the function is fx equals 30 times 2x. How many minutes will I spend in 5 months on the computer? And then that is the graph, and it goes up to 480 minutes. To realize why people care about this problem, to realize how much a waste of a time you spend on the computer, and do not double the time you spend on it.
Increasing linear functions. I get $100 from my parents for allowance every week. There's my function. How much money will I have in a week? How much money will I have after 3 weeks? Here's my graph. Yeah. How can I know when I can buy a $5,000 car? The use of these functions can be used to predict future outcomes.
Decreasing linear functions. I have $1,000 in my bank account, $50 getting taken out every month for my phone bill. My function. How much will I have after 2 months, and how much would I have after 2 months if I took out $100 a month? That's my graph. Exponential. You need to know this problem and these types of problems in general because for when you pay your own phone bill.
Exponential decay function. There are a million people watching the Super Bowl at the end of the game. The number of people that stop watching the game exponential decays by 15% every minute. Here's my function. How many people will stop watching the game in 45 minutes? By the end of the game, how many people watch the whole thing? Here's my graph. And this is why we care. We care because we want to know how much people are leaving, to know how much people watch the whole game.
The differences between linear and exponential. The end.